Hello there. My name is Stuart Almeida, and this is going to be a overview of most of the topics that we've covered so far in CS 5610 web development as part of the midterm. So we'll get right down to it. So this is the overall rundown of kind of how I am going to be talking about things over the next 30-ish minutes or so. So the general idea is that for the first part, we just kind of go an overview of most of the main topics that we've gone over in the course, some of the elements of them, and how they kind of work together. So I'll take roughly about 15 minutes. After that, we'll kind of go to a little bit of a deeper dive look, and I'd like to kind of talk a little bit more about scope in that point, like exactly kind of what it is, different levels of scopes, their overall hierarchy, and some things to kind of watch out for. And then later on as live coding, we'll kind of look at a little example of working with things by value and working with things by reference, and kind of how that might tie in a little bit of scope as well. So when we first started web development, I think as a person who is not really used to web development in all in general, one of the things I was really curious about was how exactly a web page was made. Like what were the parts to it, how things were put together, and why things work the way that they do. And now I see now that when you kind of break it down, it's actually not really that complicated for most basic web pages. You usually have these three parts that are working together in conjunction. The first part we're looking at is the HTML, which is the hypertext markup language, which basically just serves as the structure of a web page, which is, in my view, basically the scaffolding of a building or something. And so this HTML document is made up of elements using tags. So elements are just pieces that you label so your browser knows what the thing is that you're working with on. So there are a number of different elements that are on an HTML page, and elements can be modified by different attributes. And we can look at the bottom of the slide. You can kind of see a basic general example of what an element is. It basically has a start tag, which tells you what the element is or what you're kind of using the element for. Any attribute value, any attributes and values. So if you want to change something about the element, or if you want to kind of specify what the element, add a little bit more specificity to element, you can put that there, followed by your stuff that goes in the element, and then followed by the end tag as well. So the elements serve as like the building blocks of our web page. So every page that we see, everything that we work with, is just really just a culmination of different elements all together. So now when it comes to elements and tags, there are a lot of them. Right now, this is just a very small handful of most of the tags that we've probably definitely worked with in some respects. There are significantly more other than this, but these are kind of some of the big ones that you'll easily work with when you're first starting out. Things like the head tag, which includes the meta information about the page and links to other documents as well, like to the CSS or more into the bottom of the head, or not really the bottom of the head, but more towards the end of the HTML, links to your JavaScript files. The body, which there's only one, and that's where most of your stuff goes, basically for the page, the content of your stuff. You have various different headers, like range from H1 to H6, and these kind of help differentiate different levels of content and how you break things up on the page as well. You can even have just a style tag, which adds style to elements, like you can change the color and the size of things on the actual HTML page itself. Things like just tag P for paragraph, just for general text needs, or tag div, which I basically think of as like a jack of all for those that really don't have like a specific home or kind of attribute to have. Divs kind of just serves as like a catch-all for a lot of different things, and there's a whole lot more. So working with elements, using the right tags, these help to kind of build your page up piece by piece using the HTML. So if HTML is the scaffolding or the structure of the page, the CSS, I think of it as like the paint or how it looks. So it's how your web page looks. It's how you can alter your HTML elements. It can be implemented in three different ways. So the first way is inline. So you can actually, like before previously, when we were looking at the elements and the tags and the attributes and the values, that's where you can kind of implement CSS directly into an element. So it can be very pinpoint precise, but it's also not the most efficient way to handle things. So it's generally not recommended. There's the style tag that you can use, which again, it kind of covers the entire HTML page for that one HTML file, which can have its purposes. But the more preferred way to do it is to have a separate CSS file and link it back to your HTML page. So this is kind of like the example you see on the top right over here. We just have basically all the elements that we want to modify, and any selectors we might have to kind of specify them, and then all the attributes and the values that we want to change. So by just keeping it as a separate CSS file, we can apply these changes, these attributes that we're giving to our elements to multiple HTML files. So it's a lot more easier to keep things order and without having to kind of duplicate work unnecessarily. So CSS does stand for cascading style sheets. So cascading means that the order really does matter, literally, on the CSS page. So if you have two like attributes, or if you have two things for something like say H1 for your first header, for some reason, the bottom one will be the one that actually gets rendered out, just because that's the order of how things were placed in the CSS. So order does matter. Cascading does literally have effect, and how specific you get also matters when we start looking at selectors. So we could have uh, something for H1 again, for example, um, or actually let's look at like something for like P, for example, for just a general text paragraph. If we want to specify a specific paragraph within our HTML file, and not just have it affect all paragraphs, we can kind of add a class to that HTML element, so we can specify it here in our CSS using the selectors. So we can target specifically certain things that we want to target on our page pretty easily, as long as we work together with both the elements and our CSS page. And so one neat thing about CSS is that there are a lot of things that you can do on your own, just from scratch, but you don't have to do that. There, one of the tools that we had used was called Bootstrap, which is an all-in-one front-end package that basically has a bunch of pre-built and a lot of customizable options that you can just use to help add or basically build your web page. Things like navigation bars, cards, image roulettes, buttons, grid layouts and containers, kind of how we want to lay out certain things on our page. Bootstrap can, it's just one example, one tool that we can use to help really simplify that process as well. And the general idea is that you don't have to reinvent the wheel when it comes to CSS. So a lot of things that we can utilize in Bootstrap, we could make ourselves, just by using our HTML doc and using a plethora of different CSS changes to it. But Bootstrap really helps simplify that by just providing these basically ready-to-made items and templates that we can just quickly implement into our page and modify that as we want. So it's a really handy tool. Definitely helps kind of start to flesh out a much more, I'd say, more robust and more professional-looking page as you move forward. All right, so if HTML is the scaffolding and CSS is the look of a page, then I think of JavaScript as the page being able to do something or add some type of life and functionality to it. So when we look at like button clicks, maybe taking the input user from a form, we can even change how things look on a page dynamically, from DOM manipulation when you combine JavaScript and HTML together. This is where JavaScript kind of brings life to a page. And so one element of JavaScript uh, that we're kind of moving towards is the ECMAScript 6, which is basically the new standardization of JavaScript that's kind of being rolled out. It introduces a lot of new and helpful tools available for us to use regarding JavaScript. Some of these are just very couple examples. Things like import and export, which lets us create modules for our code. So basically that lets us kind of break our JavaScript code apart so that we can have uh, like a specific JavaScript file focus on one specific task, rather than just having everything in just one giant JavaScript file, which can get very overwhelming, hard to debug, hard to decode, and hard to upkeep. So being able to kind of break things up into part of different modules for code reuse is a considerable benefit to all of us. There are also new variable declarations like let and const. Before that, you really only had one variable declaration, which was the var, which had issues regarding scoping, which is something that I'll kind of talk about later. With let and const, we can kind of we can work around that, and these are now kind of the more preferred ways to declare variables when using JavaScript. And there are also cool things like temperate literals as well, which basically lets us more heavily modify string elements. and actually embed certain things into it as we as we would like. So again, those are just a couple examples of some of the things that ES6 kind of now provides and kind of what the standard is moving towards. That's kind of something that we'll want to kind of maintain going forward, just basically for all future work. So this is the basic general recipe for a web page. So we have the structure, which is its HTML, which in here I just have as a button, which is kind of has bezeled, it's white, doesn't way too much. CSS, we can change the look of it. So instead of having such sharp corners, maybe I want to have rounded edges, and maybe I want to change the color a little bit too to be orange. So CSS can help modify how the HTML elements look. And JavaScript adds a little bit of functionality to it. So maybe I do have this button, but maybe I want to do something when I click on it. So maybe when I click, I actually wanted to do something like rotate around like that. So just a very kind of quick overview of the general basic things that we had used to design a web page and kind of what led us through project one of our class. So with project one, we basically started out using just a basic two-tier client-server architecture. We just had a basic simple HTTP server. We were just serving static files to our page. Really, most of dealing with this stuff on the front end. And the benefit of that is that it's very easy to set up, very easy to get going and to work with. But there's not really a whole lot of robustness to it and scalability, and there's limitations on how far and how much we can actually do on our web page that we might want to consider expanding as we kind of develop more robust applications and pages in general. And so this is where we start shifting to more of a three-tier client-server architecture, which is what we had used for our full-stack application for Project 2, which were introduced Node.js with Express Server and MongoDB. So kind of to talk a little about those a little bit. Basically, working with full application logic, we have front-end static stuff, and we have also all this back-end action going on as well. It allows us to have higher scalability and moves us past just having a simple request response server that we had, or not a server, but like application or page that we had that we just mostly were working with in a two-tier client server. Now the downside is that compared to just a two-tier, which was a lot easier to set up, a three-tier is a lot more JavaScript, since we have JavaScript working in the front end and in the back end throughout our Node.js and throughout our Express server or in routes. And it takes a lot more work to set up, but the results are most likely going to be worth it in the end. So kind of go quickly through some of these other aspects that kind of led us down to the three-tier architecture. Node.js is one part of it. So Node.js is a cross-platform JavaScript runtime, which basically lets us run JavaScript outside of the browser. So we're working on just a two-tier architecture. We were limited to using JavaScript in the browser, but now we can actually have our own server running JavaScript, which opens up a lot of different potentials, especially when it comes to developing more robust web applications and web pages in general. Now, the neat thing about Node.js is that it's an event-driven, non-blocking, I guess, architecture, I'd describe it as, which lets us move from hard synchronous code to more asynchronous code, which lets us handle multiple simultaneous requests at the same time without stopping things from working. So when we had synchronous code, basically if you had a request or something that needed to be done, everything else afterwards, whatever code you might have, wouldn't run until that thing that you had initially requested was done. Asynchronous helps us get around that and lets multiple actions and requests kind of be handled at the same time, which is what you'd kind of expect from most modern day applications, from things like chatting, streaming, video games in general. It's the way to go forward. Additionally, Node.js lets us handle file operations and database interactivity, which is where we plug in Express and MongoDB. On just a regular JavaScript on the web page, you can't really modify files at all. But with Node.js on the server side, we can do that, which opens up a lot of possibilities for us. So Express is a minimalist web framework for Node.js that basically just simplifies the whole routing aspect that Node.js has. You don't need Express to have routes. You can just use Node.js, but having looked at just a quick example of what that looks like, it is a complete mess to work without. Express really helps simplify that whole process as well. So when it comes to routing, what is a routing? Routing is how an application handles a client's requests to a specific endpoint or path, which is called a URI. So when a client or consumer, let's say on an application, pushes a button to retrieve something, routing will help kind of direct that request to where it needs to go, to the logic that it needs to go to, into whatever the database part that needs to reach back to. So when it comes to routing, there's four general kind of standard HTTP routing methods, which are get, post, put, slash patch, and delete. And they're kind of what they sound like. Get is when you want to retrieve something. Post is when you want to add something to whatever we're working with. Put and patch are mostly for editing stuff. You want to update something. And deleting is, as it sounds, just to straight up delete something. And MongoDB is the last part of that, which is basically just the storage. So specifically, MongoDB is a document database that stores data in JSON format. So compared to just the regular static files that we have, mostly dealing with on the front end, this kind of helps serve as our storage for whatever data we might be working with. There are two different ways you kind of query stuff from MongoDB. You can use like aggregation pipelines, which let you help group, sort, perform calculations, and modify data, and a whole lot more, which is really useful. Say you had like a site that or application that has like reviews for a product or something, and you want to be able to get the average number of reviews from all consumers of that product. Well, an aggregation pipeline will help you gather all the reviews that you might have stored on your MongoDB collection and actually perform that aggregation or that aggregated data that you're trying to get out of it. You can also use CRUD operations on database documents too, like create, read, update, and delete, which basically tie in heavily to the routes that we have for Express. So that's kind of how those two are able to work together pretty easily. And so altogether, I like to think of it as kind of like a restaurant when I try to visually think about how Node.js, Express, and MongoDB work, since it's a little bit more, since we're kind of expanding architecture quite a bit, so it's kind of a little bit tricky to understand how things actually, at least initially for me, work together. But for me, Node.js is basically like the kitchen. This is where we have all the logic. This is where all the work is, all the cooking. This is where all the magic is located at. It's here in Node.js. Express, I think of it as like the waiter that takes the orders or the inquiries from the customers, and we think of these as the HTTP requests, depending on what they're trying to do or get. Say maybe they're trying to order a meal, or maybe they're trying to get information about something, or maybe they're just trying to get the check and leave. I think of Express as like being able to direct those requests to where they needed to go. In MongoDB, I think of it just sort of as the pantry in general. And just a quick little example where we just have all our ingredients stored and we can retrieve them, change them, take them out, put more stuff back in as we need to as we go forward. So this is just a quick overview of all the things that we've kind of covered so far in our class. I'm going to break this up a little bit. So the next portion will focus on talking a little more about scoping and some of the topics associated with that. All right, just want to shift gears a little bit, talk more a bit about scope, a little in depth, and how that can significantly change kind of how you have your functions, have your program kind of laid out, or as you develop it. Scope in general is basically just the accessibility or visibility of variables within your program. So depending on how you declare a variable or where it's declared may affect the scope of that variable. And depending on what you're doing or what you're working with, having access to certain bits of information may change depending on, again, like what it is that you're trying to do. Say you have some information that you want to have access, that you want other functions to be able to access to. You have to keep the scope of that bit of information in mind and how you kind of go about that process. Or maybe you have some type of function that does something, you declare a variable inside of it, you just want that variable to live only inside that function and not really have any use anywhere else. You don't want it to be called upon by another function, you don't want it to be referenced anywhere else. That's kind of some of the things that you need to keep. That scope helps you maintain certain access to certain bits of information as you kind of work through your program. So there are a couple different levels of scope to consider. I think there's really generally only three, but you can kind of break them up a little bit more, which we kind of do here. So you have your global scope, you have like your function scope, which is kind of like your local scope. You have block scope, which was introduced with ES6. or well, it was more expanded on ES6. You have your lexical scope, and you have, in addition to the ES6, which is like module scope, which is just a little bit step down from global scope. So first one we'll look at is global scope, which are kind of when we think of the hierarchy of the different levels of scope. Global scope is pretty much at the highest level. So it's any variable that's declared outside of a function or any block. So really, when if you look at the example on the right, we have a variable named x. We declare it using let, and we assign it the string hello. So that variable can be used anywhere in the program, as it is right now. It can be used outside of function. Anything outside of the function can use that variable. Code inside of a function can also access it as well. So in the example on the right, we have a function just called f1, and in it we're just logging the variable x. And then we call f1, and then if you were to actually run this, it would just print out hello on your terminal. So global scope is kind of a tricky thing to work with. It's generally advised not to really have variables within the global scope, just because some of the issues that can arise with it that we'll kind of talk a little bit about later on. So the next one to consider is function scope. So it's any variable that's declared within a function using let or const, and we'll kind of go a little bit later on specifically why it's let or const and not just var anymore. So looking at the example on the right, we have a function called f2, and inside that function we have a variable called y that's declared with let, and we assign it the string hello from f2. In this case, what we're trying to do is I'm trying to call that variable directly on the outside by logging in the console, but I get an error because y is not defined, because the variable y is declared inside the function, but I don't have access to it on the outside. So right now, only the function has access to the variable y. So each function has its own scope, and again, like I mentioned, you can't use variables from inside one function directly inside another function. So things are kind of restricted to where they are declared. The next thing we have is block scope, and it's basically kind of similar to functions. It's variables that are declared within these curly braces using let or const specifically. And within that case, those variables have their own scope as well. So it looks pretty similar to the previous example when we're looking at function scope. In this case, on the example on the right, I have just a simple little block of curly braces. Inside I have a variable z, declare let, and I just assign it the string hello from block. Again, I try to call from the outside, but I'm not able to. I get a reference error that z is not defined, again, because I don't have access directly to that variable because it's confined within the block that I declared it in. So this can apply to things like if-else statements or loops, or just, again, just a plain old just do curly braces anywhere out in your program. And this can be particularly helpful, again, with encapsulation, when you're trying to hide data from the global scope. We want to try to keep things confined to a specific block or function or something like that. You want to be able to maybe manipulate it or use it, but you don't want it to be readily editable or accessible from the outside. Next type of scope is lexical scope, and I sort of look at this as like a nested version of scopes where you have a variable declared inside of a function that can be used inside that function or in any of its nested components. So in the example to the right, it's a little bit of expansion of some of the previous earlier functions that we had. So in this case, I have a function called f3, and inside that I have a variable x that's assigned the value of 10. And inside function f3, I have another function called f4. And inside that function, I have another variable that's called y, and it's assigned the value of 20. And inside f4, I actually log me adding x plus y together. And then outside of that, call f4, and then outside of all that, outside of all the functions, we actually just call f3 to kind of begin that process of invoking these functions in general. And if you actually run this, the output is 30. Since we have x is 10, y is 20, just add them together. So it's still kind of a one-way relationship though. Like you cannot access y directly from inside f3, even though f4 has access to it, but f4 has access to the variable that was declared earlier inside f3. Okay, and we're going to take a little bit of a quick side tour. I say quick, but closures can really kind of get a little bit complicated. So I'm going to try my best to kind of go over what I feel like I know about closures in general. So closures are basically like a combination of a function and the lexical environment that it was declared in. So the environment that we call includes any of the in-scope variables when the closure is made. So really what it means is like an inner function kind of remembers outer variables even after the outer function that it's a part of has already finished running once. So in the example on the top right, we have a counter function, and inside that we declare a variable called count, and we initially set it to 0. And inside the counter function, we return an anonymous function that takes the count, increments it 1, and then logs it out into the console. And so outside of all these functions, below that, we have a variable called let's count, declared using counts, const, and I initially invoke the counter function and return a reference to the inner function inside the counter. And so below that, I call let's count 3 times. And if you actually do that, what you get on the output terminal, it would actually it would increment the count. It would display 1, 2, and 3. Even though initially the count variable was only declared inside the counter function itself once. But the inner function kind of still remembers that. It still keeps that. It still is able to kind of reference it because it's in the same lexicoscope as that inner function is itself. So the neat thing about closures is that every call to that outer function, if you have like different variables, makes a new closure. It makes a new independent copy of that environment that's in. So in the example on the bottom right, it's very similar outlines, same counter function in general. But this time I have 2 different variables. I have one called let's count A and one called let's count B. And I do the same thing. I have both of them invoke the counter function, and it should be returning the inner function to both of those variables. So below that, I call let's count A 2 times, and I call let's count B 1 time. And if you actually run this function, what you see is that you'd get for let's count A, for those first 2 calls, it'd be 1 and 2, and then for let's count B, it would just be 1 because it creates kind of a new independent copy of that environment that the function counter was a part of. So closures kind of get can get really complicated when you're trying to we start working with more like a lot more nested functions. And I know as we kind of get closer to working more with React, closures naturally kind of have a role in that thanks to the different states that we're working with. But I just wanted to kind of give an overview of that since that kind of ties into the lexical and the function scopes that we've kind of already gone over. And then the last thing is a module scope, which is mostly introduced in ES6. Just quickly go over this. Basically, it says that every module has its own scope. So unless you explicitly export a variable or as a function, it won't really be available outside of that module itself. So it keeps things contained within the separate modules that you're working in. So you can't have two modules. You can't have one call on stuff from another module unless you explicitly export it, again, to kind of keep things secure and where they need to be. So when working with scope, there's a couple things that can kind of make things a bit trickier, get things messy to keep in mind. One thing is, again, using global variables too candidly or really at all. You want to try to limit your use of global variables to reduce the chance of any collisions or any unintended actions. That kind of ties into the next point here of using var instead of let and const for variable declarations. Var is kind of outdated. Var can be function or global scoped depending on when it's declared. But var isn't able to be block scoped. So if you have a block scope and you somehow, for some reason, you use var inside of it to declare a variable, that variable is basically global scoped. So you can use it anywhere whether you intend to or not. Another thing to keep in mind is when you don't declare variables, that automatically defaults them to global scope. So if you have a variable that you need to use, declare it using let or const. To always keep that in mind. And variable name reuse can be helpful, but it can also make it a little bit trickier to spot unintended errors. So if you have a variable inside of a function, for example, you can name it something like x, and you can have another variable outside of that function also called x, just say on the global scope. That's totally legal, but if you're trying to spot any errors or trying to debug something, having those similar variable names can kind of make things a bit tricky. So try to keep things specific to where they need to be, name them specifically what you need to as well. So there's a quick overview of scope and some of the applications that you can use for and some of the things to keep an eye out for. Okay, so the last thing I want to touch on, I just do my live coding example, is take a look at pass by value and pass by reference. Like as we get more and more into JavaScript, as we delve more deeper into working with more functions, how we kind of handle the data that's being passed around will typically depend on the type of data that we're working with and whether or not we want it to change when we want it to. So when we're passing around different data types, how it'll actually change or not change, again, depends on its type. So there's like two general types. There's primitive types and then I guess there's non-primitive types. Primitive types you can think of sort of as like numbers, strings, and booleans. These things, when you pass them around the functions or otherwhere else in the program, these are passed by value, which means that a copy is basically made of that thing. And when you start working with other things like non-primitive types, like objects and arrays and functions, those are passed by reference, which means that they basically point to where that object is located in memory. So when you make changes to something like an object, it'll actually change the original one as well, even if you think you've made a copy of it. If you did not make a correct copy the way that maybe you should have. So let's take a look at the first example just by working with primitive data types. So let's say I have a variable. I'm going to declare it, give it a value of 10 initially, and below it I'm going to assign another variable, y, and I'll just set that equal to x. So I'm assigning x to be also y as well. So to kind of see what's happening, so we're going to do console log before any changes, and then we'll just splay out the values of our initial variables. We'll just do x first, and then we'll do y. Great, so we'll save, run our program, and you'll see here in the terminal that before any changes are made, what we have output is that x has the value of 10, and y also has the value of 10 as well, which is great. But let's say instead that we want to, or we somehow change the value of y to something else. So instead of 10, we'll have it be 20. So we'll just take a little copy of what we've done before, make a very quick change here, and call and log out all these, log out our variables again on the terminal to see what's changed, if anything. Save, run our program again, and in this case, we'll see that. So before any changes were made, both x and y had the same value, which is just 10. And after we made changes, see that x still has a value of 10, but y now has a value of 20 instead, because again, we reassign the value of y here. But just because we changed y doesn't mean that we changed x, even though we initially had this going on up here at the top. Because when we had declared y, we passed the value of x to y. So we basically made a copy of the value of x. And so whenever we make any changes to y, we're not actually changing x after the fact. So that's passed by value. But instead, if we're working with more non-primitive data types, like an object, for example, that instead is more passed by reference. So let's say instead I had an object here. We'll just say let object, and we'll just have a simple key value pair here. We'll have name, and then we'll do Jack for this one. And we're going to change this up a little bit. We're going to, so let's say we said we had a function that we pass our object into. We want to change it. So we're going to change, call it function change. We're going to say, let's call it ob. And in here we'll say ob.name is now instead Stephen. So we're going to reassign the value of the key that we have in our original object. And to see what's actually going on inside, we're going to just have a little console note here. So inside the function, we're going to output the change we just made. And then outside of the function, we're actually going to call it. So we're going to call change, and we're going to pass in the original object that we had created at the top of this. And to see the issue, we're going to have another log out here that will output what we think should be the name of our objects. So originally we had declared an object and we had given in, it's just a simple key value pair where we have the name and that value is Jack. And we have a function over here called change where we pass in the object into, and inside the function we change the name. We reassign the value of the key to instead be Steven. So when we save and we run our program, what we can see here is that inside the function it's being logged as Steven, which is fine because that's what we changed out here. But outside the function it's also being logged as Steven as well, because when we had passed the object into the function, because it's non-primitive data type, we're passing it by reference. So we're really passing it by the location that it's stored in memory. So any changes that we make to the object, whether it's inside a function such as this or even outside of it, it's going to carry over. Whether or not that's an intended effect or not, if you want to get around that, the easiest way to do it is to actually just make a separate copy of the object inside whatever it is you're trying to work with if you don't want to change the original copy. So that's just a quick overview of some of the difference between pass by value and pass by reference, and just things to keep in mind as you continue working furthermore on JavaScript functions later down the line.